All right, welcome everyone. Sorry about the delay. I'm restarting my weekly review. I record now. So again, this is a weekly review for the first week for Organic Chemistry 1, Chem 2323. So if you're not here for that, you're probably in the wrong place. And yeah, so there is a virtual component as well as an in-person component. So you can come to either or. Virtually, you'll have to go through through the link in our website. And then in person, you can come to the library in room 3.610, which is on the 3rd floor. And of course, these reviews are going to be Wednesdays from 1 to 2:15 p.m. every week. Okay, so there should not be a change. If there is any kind of cancellation or anything like that, we'll let you know. Okay, any questions so far? Okay. All right, so just a reminder of what is going to occur during these sessions is it's going to be a review of material covered in class. You know, go figure. So it's very similar to SI, but it's the peer tutoring version of it. And we'll offer some practice problems throughout / at the end, depending on each session. And again, I want to remind everyone that this is a supplemental component to lecture. Okay. This should not be your primary resource of information. We want lecture and you know, your lab sessions and your TAs to be your primary resource. Of course, the Student Success Center aims to help students get the best grade they can and do well in their courses. This is peer tutoring. I'm a peer tutor within the Peer Tutoring Center. Of course, there's also PLTL, there's also SI. So choose what model best fits for you. And actually, you don't have to choose. You can do all three if you want to. Okay? But we will, of course, help you in any way we can, as long as it's not breaking any academic dishonesty. Okay? All right, and I just want to remind you guys, just bear with me if there's any technical difficulties, as I have to, since I'm doing both in-person and virtual, as well as dealing with the camera, the audio, switching back and forth between tabs. There might be some hiccups here and there. I will be monitoring the chat on Blackboard, as well as potentially answering questions in person. Okay? All right, so that's a general overview of the of this weekly review. But a couple of information about me. Let me zoom out here a little bit. Oh, cancel that. Okay. All right, so again, my name is Shri Yarlagada. I obviously tutor organic chemistry. I'm a team leader with peer tutoring here at the Student Success Center, which is located in the basement of the library. And a little bit more about me is this is my 4th year tutoring organic chemistry. So believe it or not, I've been doing this for a while, and I absolutely love it. You'll understand what I mean when I say organic chemistry is fun. That might sound absurd to you, ridiculous, even crazy, but trust me, it can be very fun. I personally love it. And my goal is to make sure you guys enjoy it, because if you enjoy it, it won't seem as troublesome or stressful, okay? I've been doing weekly reviews for the past 2 years. This is my 3rd year doing it, so I have a little bit of experience in that field. I'm also a pre-med student, and I'm president of Bowling Doctors, which is a pre-med organization here on campus. So if you're a pre-med and if you have any questions, pre-health even, you can always reach out to me if you have any questions about that. So beyond these weekly reviews, I also tutor in the peer tutoring lab, which again is located in the basement of the library. My hours are Monday 3:30 to 6:30, and Wednesday 2:30 to 5:30. Okay, so if we ever run out of time here in the weekly reviews, if you like my tutoring style, and if you want more either one-on-one or just extra practice, feel free to come to my shift hours. Of course, peer tutoring is available Monday through Thursday, 10 a.m. to 6:30 p.m. and Friday 10 to 4 p.m. and then Saturday is virtually 12 to 4. Those hours and the courses we support, all of that information is going to be online, which I'm going to quickly cover. So 1 second. So here's the peer tutoring website. So all of our information, here's the contact information, our room location, the dates we're open, any cancellations, how to schedule an appointment if you need an appointment. Drop-in tutoring is what we're known for. Of course, we also have appointments, exam reviews, and weekly reviews. So this is a weekly review, CHEM 2323, Wednesday, 1 p.m. to 2:15, and here's the link to join virtually. Okay. And then again, if you want drop-in tutoring, you can check out the supported courses, and you can see all of these courses that peer tutoring helps with, SI helps with, and PLTL helps with. Okay. And then, of course, here are our drop-in tutoring hours. And yeah, that's it. So everything that you could possibly need will be in this website. And if you have a question outside of this, feel free to contact us or just come in person, say hi, and check it out, see if it's right for you. All right, so let's see. So any questions about the Student Success Center or peer tutoring? And the reason why I'm going a little bit in depth with this is because usually this course is taken by sophomores, and due to virtual learning last year, most of you have not had the full in-person experience. So hopefully a little brief overview of our services will help you better understand everything that we can do for you. Any questions? Okay, if you guys think of any, just feel free to type it in the chat at any time. Okay, let's go back to our weekly review OneNotes. Okay, so that's it for that. All right, so let's go to the introduction. And let me unmute. Okay. So just a little introduction before we get into the actual concepts, which we'll get to momentarily about week 1 and week 2, or chapter 1 and chapter 2. You've taken general chemistry. Now you're taking organic chemistry. And then next year, you might have to take biochemistry depending on your major and the the field you're going into. Okay, most people also take, at the very least, biochemistry 1. So general chemistry's concepts are very minimal to organic chemistry. I would say organic chemistry on its own is a very unique science and a unique subject, which is why a lot of people find it difficult, actually, because it's nothing like anything else. So it's not necessarily hard, it's just different, which can be difficult for people to understand how to study and how to grasp those concepts because they haven't been exposed to that before, which is completely fair. But that's what we're here for, to make it easier on you. Biochemistry is a little bit more general chemistry, and there is a little bit of organic chemistry concepts, but you will use more general chemistry knowledge for biochemistry. And obviously, this doesn't really apply to like physics or math or anything like that, or any of the medical like anatomy and physiology, biology. Well, technically, there is some organic chemistry in biology and anatomy, of course. But yeah, other applications for organic chemistry is it might show up on the MCAT if you're taking that. I'm not sure about any other standardized testing. I know the GRE probably doesn't have OCHEM. I don't know about the PCAT or the LSAT. I'm assuming, hopefully, the LSAT doesn't have organic chemistry. But yeah, something else about organic chemistry is you probably heard the term weed out class, as in when people are exposed to this class, they get scared and they drop out of becoming, a doctor or a pre-PA, or sorry, a PA or a medical researcher, because they think this is too hard. And it can be, of course. I'm not saying it's easy, and anyone who doesn't get it are invalid. But which is why it's considered weed out class. But I fully believe here at UT especially, and everything that we help with in peer tutoring, PLTL, and SI, really benefits you guys. We have a lot of resources that you guys can utilize. So with all this combined, I believe this course should be manageable. If you're ever feeling stressed about OCHEM, just come talk to me. There should be absolutely no reason why any students of mine should feel stressed. Okay? Gonna quickly see, is it frozen for anyone else? So I haven't moved the screen. Are you still able to? It's fixed. Okay. Sorry about that. All right. So I've covered that. So we're going to briefly look at the syllabus. I know you guys already done this with your professor, so I just want to give you guys a overview of the semester and how what the game plan is for my reviews. Okay. Sorry, each time I switch tabs, I have to do this. Let's see. Okay, so here is Dr. Novak's, one of the organic chemistry professors for OCHEM 1 syllabus. Of course, you have all that information. They covered it. So today is September 1st, so you should have had 3 lectures already. And it looks like it is Tuesdays and Thursdays. So you covered definitely chapter 1, and you started to cover chapter 2, okay? And which is exactly what we'll review. And there's a list of topics and concepts that I have that I want to discuss regarding chapters 1 and 2, and they might be a little bit mixed. It looks like your next quiz is not until about 2 weeks from now, or 2 weeks from yesterday. So before then, looks like it's right on chapters 1, 2, and 3, I'm assuming. Looks like alkanes, cycloalkanes, and cyclic conformations. So by then, you'll be ready. And yeah. Okay. Let's see. Stop recording. Let's go back to weekly reviews. All right, so I'm gonna start with chapters 1 and 2. Let's see if I can get rid of this. Oh well. Okay, let me zoom back in. Okay. And again, feel free to type in the chat. Let me know if you have any questions. Stop me at any point. So it's chapters 1 and 2. We'll talk about the octet rule, formal charges, molecular formula, Lewis structures, and line angle drawings, how to go from formula to structures to the full line angle drawings that OCHEM is known for. Periodic table trends, there isn't too many. I know you guys covered it in Gen Chem, but there's a couple specific ones for OCHEM. And there's an acronym called BEAN. Hopefully you guys have heard of it. If not, I'm honored to be the first ones. Hybridization, it might be chapter 2, depending on professors. Functional groups, sigma and pi bonds, resonance, and within resonance. Resonance is a very important topic to organic chemistry, and acidity and basicity is also a very important topic. In fact, you'll have acidity and basicity questions even until the final exam of OCHEM 2. So if you understand it now, that foundation will still be there, and it will still help you for the next year. All right? And of course, hybridization is also a very important topic. Okay, so give me one moment while we head into the lesson. And before that, I want to open up to everyone to see if you guys have any questions about any of these, any general questions. Okay, if there's no questions, we will get into it. I'm gonna zoom out, scroll down. Okay, so once again, bear with me as this has been a while before I've done it. Okay. Sorry, one moment. Let me stop sharing the screen for a sec. Draw. All right, I got it. Okay, so octet rule, hopefully this should be a review from general chemistry. Oh. Okay. So octet rule, obviously, you have to have 8 valence electrons, regardless of what that is. And here's some normal pattern behaviors that you should observe. So we'll talk about 3 main atoms in the periodic table that you'll use a lot in OCHEM. Let's see if I can zoom out. How do I exit this? Okay, anyways. Not that. Is there an exit button? All right, well, that's fine. So for carbon, you should have 4 bonds. So 4 bonds and 0 lone pairs. Okay. For nitrogen, you should have 3 bonds and 1 lone pair. Okay. And then for oxygen, you guessed it, 2 bonds, 2 lone pairs. Easy as that. Hi, are you here for OCHEM?
Yeah, I was watching you online and couldn't stop hearing you, so I'm just kidding.
Okay. Yeah, no problem. Is the audio not working?
No, it is, but I could like hear you and
Okay.
online, so it was
Yeah.
weird.
Sure, yeah, no problem.
Do you mind if I'm
Yeah, no, you're good, you're good. All right, and then for oxygen, we have 2 bonds and 2 lone pairs. Actually, do you mind signing in for me also?
Oh, yeah.
Thank you. All right, so those should be the patterns for the most important atoms in OCHEM: carbon, nitrogen, and oxygen. Okay. And again, octet rule is important because if your octet rule is broken, that means you have a formal charge that's not neutral. And if you notice how we do octet rule and formal charge, so octet rule, you just count all the electrons being shared with the atom. So each bond is 2, and each lone pair is 2, right? So 4 times 2 is going to be 8 electrons. 3 times 2, 6, 1 lone pair, 8 electrons. And then 2 and 2 is going to be 8 electrons. So this should be the normal formal charge. Octet rule, it should be like that. And then, let's see. And if you have any questions, let me know. All right, so should mostly be a review. If not, let me know. If you guys have any questions. Okay, now moving on to formal charge. So just to review, formal charge is going to be, so you're going to draw a line between all the bonds because you're only counting one aspect of it. Okay, and with valence, with lone pairs, you're going to count all of it. So bonds, it's going to be half, and then lone pairs, it's going to be full. So here I have 4 valence electrons. Nitrogen should be 5 valence electrons, and then oxygen is going to be 6 valence electrons. Okay? And this should stay consistent, and if carbon has, if any of these have more or less than it already has, it's going to be, there's going to be a formal charge of either positive or negative. And again, that should also be a review. Okay. Does anyone have any questions? Why do we draw the lines? Okay, yeah, great question. Are you talking about the dotted lines? Okay, well, that's morally for me, per se. It's like an imaginary line. I'm not sure if you guys can see the mouse, but you're cutting essentially, this carbon essentially has 4 bonds, 4 electrons, because each bond is 2 electrons, right? So one side gets this, and the other side gets that. So when we're doing valence electrons, we only count the one that it contains. And this makes a little bit more sense when you look about the Lewis dot structure. So when you make a Lewis dot structure for any atom or compound, you have to look at the valence electrons, and you put a dot for each electron it contains. So this is another way of viewing it. Does that answer your question? Okay, cool. All right. Trying to go back. Okay, I think I figured it out. Okay. All right, there we go. All right, so we've gone over the octet rule and the formal charge. Let me give you guys a couple of problems for formal charge and see if you guys can let me know what the formal charges are, and then we'll head into number 3, molecular formula, Lewis structure, and line angle drawings. Okay, so going back to draw. So what would the formal charge be for something that looks like this? So let's say that's number 1, number 2, then number 3. So tell me if it's breaking the octet rule, or if it's good, and then also tell me the valence or like the electrons it has, or like the formal charge. I mean, like this formal charge. I'll give you guys a couple of seconds, 30 seconds. Okay. Let me know if anyone has some questions. Okay, questions. All right. So I'm gonna go over it. So remember octet rule, we're going to count each bond, and it's going to have, each bond has 2 electrons. So anything, we want the magic number, which is 8, and if it has more or less, that means something's wrong. Okay, so carbon, I see it has 5 bonds, and that are 5 times 2, that means it's 10. So it already breaks it, so I'm just going to put an X. Nitrogen has 4 bonds, so it's technically good because it fulfills this octet rule. Oxygen, I see 4 bonds, which is good, but I also see 2 extra valence electrons, or regular electrons. So it's also not fulfilling its octet rule. Now, formal charge. So remember, we have to cut each bond and then count each of our electrons, which are these red dots. So I see 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. Okay, and here I see 1, 2, 3, 4. When I cut it like that, so this has 4, and then oxygen has 3, 4, 5, 6. Okay, so formal charge-wise, do you guys know what carbon would be? -1? Yes. Okay, and the reason why it's -1 is because carbon is supposed to have, and this is like the formula, carbon is supposed to have 4, but it has 5. So you do whatever it should have minus whatever it does have equal to your formal charge, which in this case is -1. Okay, so it's kind of like backwards logic. So if it has more, it's like a negative number, and if it has less, it's a positive number. All right, so nitrogen. So if you apply the same concept, it should have 5 valence electrons, and it has 4, so it's going to be +1. So it's missing a valence electron. And then oxygen, it's supposed to have 6. It does have 6, so it's neutral. Okay. So if I were to ask you guys which of these is the most stable atom, what would your answer be? Okay, one person said oxygen. I got 2 oxygens. Any other answers? Okay, so you guys are correct. It is going to be oxygen, and the reason why, actually, no, it's carbon, because carbon has both the octet rule broken as well as the formal charge broken as the least stable one.
So carbon is the least stable.
Yes. Did I say that backwards?
Yes.
Okay. Good. Sorry about that. So if we were to rank it, which you guys will do a lot, this is going to be the most stable to least stable. So most to least stable. Okay. So carbon has its octet broken, and it has a -1 charge. So it's going to be carbon here. Nitrogen has its octet fill, but it's a formal charge of +1. But oxygen has its octet broken, but its formal charge is 0. I don't think they're going to be like nitty-gritty about stuff like this. So don't worry about it too much. But in this case, I believe octet rule is more important. So we're going to put nitrogen here and then oxygen here.
Nitrogen is the most stable.
Yes. Okay. Any questions on that? Any questions on formal charges? Because that's the last time I'm going to do it. All right, cool. All right, so let's scroll back. I'm going to zoom out a little bit. And if you guys ever need to see something, screenshot something, just let me know. Of course, there's a YouTube recording. If you guys want to just use that later. All right, so now we're going to go to molecular formula, Lewis structure, and line angle drawings. And just a reminder, this list is not, we're obviously not going to get through everything. This is kind of both today and next week. We'll just get through whatever we can. Okay. All right, so molecular formula, Lewis structure. So I'm going to actually work backwards from line angle drawings, and then we're going to go to Lewis structures and then molecular formula. Okay. So have you guys started doing line angle drawings? No. Okay, so this is new.
I mean, I think we kind of did an addendum, but
Okay. All right, so line angle drawings, and then Lewis structures, which is really, we'll talk about it. And then you have a starting molecular formula. Okay. All right, let's see. So let's say we have something that looks like this. Okay. So if you've never seen this, this probably looks gibberish. But each of these vertices is a carbon, and I don't know why it's doing that, I'm sorry. So each of these points is a vertex, okay? Sorry, each of these points is going to be a carbon. So in line angle, there's a, I guess, quote unquote rules, which I'll write here. Carbons / hydrogens are not shown. Okay. Hydrogens may be shown if it's bonded to anything other than a carbon. Okay? So if it's bonded to an oxygen, like alcohol, or a nitrogen, like an amine group, then hydrogen will be shown in your line angle drawing. And we'll see cases like that. But if it's bonded to carbons, it's not going to be shown. And carbons are also not going to be shown, I believe, at all. I can't think of any reason it's ever shown. Yeah. Okay, so now let's try to take this line angle and go to Lewis structure. Okay, let me see if there's any questions. We've seen these. Okay, perfect. So a couple of professors might have, you probably have different orders. So if you've seen it, that's great. So each carbon, each vertice is a carbon. And so we're just going to do the carbons first. And then we'll add in the hydrogens. Okay? So obviously, if I leave it like this, it's going to be wrong, right? Because each of these carbons have either one bond or two bonds, and they should have 4 bonds. Okay? So we have to manually remember that each carbon is supposed to have 4 bonds. So if you add hydrogens to get there. So each of these outer ones are going to have 3 hydrogens. And this is actually called a methyl, that carbon. The CH3 is called a methyl. And we'll talk about nomenclature. I think that's next week. Still very early, not an error. Okay, so and each of these middle ones are going to have 2 hydrogens. Okay, so this is probably the Lewis structure you guys are familiar with, right? And then let me zoom out here or go this way. And then now if we go all the way to our molecular formula, now we can count the individual atoms and the hydrogens. So we have C5 and H. So I have 3, 6, 7, 8, 9, 10, 11, 12. So C5H12 is one of the most common molecular formulas and examples that they use a lot in OCHEM. Okay? So any questions on this? Let's see. All right, perfect. Okay, so I'm gonna display another line angle, and I want you guys to practice. So go from that to the line angle, to the Lewis structure. And then also tell me the molecular formula. Okay, I'll give you guys about a minute or so. Because usually I think you go the other way around, but if you're able to go backwards, hopefully it should be not too bad. All right. If you guys are still working, that's fine. I'll get started. So for now, I'm going to start with my carbon chain, which looks like this. And then at the very end, I have oxygen. Okay, so I'm going to fill in my hydrogens first. And then this one has 2. This top one has 2. And this bottom one is connected to an oxygen with a double bond with an oxygen. And then this oxygen is bonded to hydrogen, and we have to, if we're doing Lewis structure, we technically have to show that bond. And I guess technically we also have these lone pairs. Okay. And if you look at each of the carbons and each of the oxygen, they all have, carbon has 4 bonds, 0 lone pairs. Both of these oxygens have two bonds here and here. Double bond is also 2 bonds, and then 2 lone pairs. Okay, so everything looks good. There's no formal charges or no unhappy atoms. All right, so molecular formula, hopefully this should be the easier part. So we have 4 carbons, so C4. So 3, 4, 5, 6, 7, 8, H8, and then O2. Okay, did anyone not get that or need any help?
I didn't, but I didn't see that.
You didn't see this O?
Yeah, no, I didn't draw it here.
Okay, that's fine. All right. Okay. Do you guys have any questions about line angles, Lewis structures, molecular formula? Okay, so let me just give you guys, I'll draw a very long line angle, but just to kind of show how everything looks. So you could have a halogen, let's say fluorine, would be bonded like that. And then let's say you have a double bond here, or a carbonyl. You could have multiple carbons bonded to the same thing as long as it doesn't break any octet rule. You can have an amine right here, NH2. Something I forgot to mention in a line angle drawing is lone pairs are not shown. So carbons, hydrogens, and lone pairs are not shown, and hydrogens are only shown if it's bonded to anything other than a carbon. Okay, so that's why when I drew this, I didn't draw any lone pairs, and then in the Lewis structure, the lone pairs appear. Okay. All right, so this you guys can practice later on, and it's really easy to make your own line angle drawings and practice. So like some classes have difficulty like making your own practice problems, but OCHEM I think it's very easy to do on your own, since you can just be creative with it. You can build whatever you want. But yeah. Okay. All right, so moving on, we have periodic table trends. Okay. And then we'll probably do that and talk about hybridization, and then we'll probably have to stop until next week. Okay. So periodic table trends. So has anyone heard of Bean? Have you? Okay. Anyone in the chat? No. Okay. So that's completely fine. Let's say this is your periodic table. Looks like a castle. All right. So we have the B here. We have the E here. A, and then N. Okay, any guesses what B stands for? Or any of these? E, A? Okay. That's a good guess, but no. E is correct. E is going to be electronegativity. Okay. Someone said affinity. No. So A and B is going to be acidic and basicity. Okay. Hope I'm not spelling anything incorrectly. And N is technically, well, not technically, it's called nucleophilicity, which is something you don't have to worry about until next year. So don't worry about that right now. So as you go up the periodic table and to the left, your atoms become more basic. As you go down the periodic table and to the right, your atoms become more acidic. As you go up and right, your atoms become more electronegative. Okay? And then we'll also talk about the most popular atoms you have to know. So we have our carbon, nitrogen, and oxygen. Okay, these are your bread and butter. Next to oxygen, I believe it's fluorine. Hope I'm not getting that wrong. So you have your halogens. You have fluorine, chlorine, bromine, iodine. Underneath oxygen, you have sulfur. Underneath nitrogen, you have phosphorus. And then underneath carbon, you have Si, which is silicone. Okay, and then after fluorine, after your halogens, you have your noble gases, which are actually not important in OCHEM. Okay, and then on this side, I guess just hydrogen, but not really. And then there's sodium and potassium, which I'm not sure if they're directly underneath. I think it's Li, Na, and then K. Well, I don't know the exact order, but Li, Na, and K are also important. Less important, carbon, nitrogen, and oxygen are going to be the most important ones. And of course, hydrogen and the halogens. Okay? So between phosphorus and carbon, which is more basic? Carbon. Okay, and Na does not stand for autoionization. Yes, between carbon and phosphorus, carbon is more basic. You know, you don't have to really think. You can look whatever's closer to the beat. And between fluorine and bromine, what is more acidic? No, you can go ahead. Yeah. Yeah, bromine. And obviously there a little bit more going on. Acidity has to do with size. As you go down the periodic table, the size increases. So between oxygen and sulfur, which will be when you rank oxygen and sulfur is going to be something that you'll talk about a lot. Sulfur has a bigger atomic size, so it has more shells. So when it has a negative charge, because acids turn into conjugate bases by donating a proton, right? So when that proton leaves, a negative charge appears and it turns into a conjugate base. That negative charge is obviously unstable, right? As far as in the formal charges realm. So that negative charge, when it spreads across a larger atom, it's going to be more stable than spreading and concentrating on a very smaller atom. Okay, so that's kind of like the theory behind acidity and a little bit of a preview of acidity and basicity. But these are the periodic tables you have to know. You don't really use this one. This should already be ingrained in you through Gen Chem. But if it's not, there it is. Make sure you know what bean stands for. Okay. Any questions on this? And like I said, don't worry about nucleophilicity until second exam. Okay. Do you have any questions?
Is that second exam or next semester?
No, second exam. Yeah. So Unit 2 of OCHEM 1. All right. So I might actually stop it here because hybridization is going to be a big topic. But hybridization of functional groups, sigma and pi, are kind of in one category. Acidity and basicity we kind of already talked about, but there's another acronym called ARIO that it's like a checklist to determine which compounds are more acidic and more stable than the other. And if you know acidity, you should know basicity. It's just the reverse, more or less. Resonance is a big topic, but I'm hoping through lecture it should more or less click. If not, we'll do some practice problems next week. Function groups is actually a next week topic in lecture, so it's not urgent. So if you guys have any questions or want to see more, from these first few, let me know while we have these last 5 minutes. If you have questions about weekly reviews, just OCHEM in general, let me know. Otherwise, all of this, I'm going to copy it, and we're going to talk about it in next week. Just label this chapter 2. We'll finish chapter 2 and start with chapter 3. Since we had a couple of technical difficulties, we weren't able to finish chapter 2. But this hopefully should be a review by the time you guys get to next week. And chapter 3 is also a lot of topics. But yeah, any questions? Okay, if not, I will see you guys next week. And again, this is recorded, so if you ever want to study for an exam, like final exam, unit exam, you can always go to YouTube and review it later on. All right, and once again, you guys are open to come in person, virtual, or view the recording on YouTube. All right, thanks for coming, everyone. I'm going to stop the recording now.